All right, in this video, we're going to solve nonlinear systems of equations by substitution or elimination. And it tells me any method we wish. If you prefer graphing, go for it, but no. Okay, let's use substitution or elimination. Sometimes the way that they're set up, you can only use substitution or you can only use elimination. But for the most part, you can use either one. And so it's just kind of a preference. So on this first one, my y's are pretty close to canceling out. Notice here that I do have an x and an x squared. Okay, and let's actually just start I'm going to put what these equations are. So when you have an x to the first and a y to the first, this is a line. You have a squared term, but the other one is not. So this is a parabola. Okay, so if you think about those two shapes, at most I can have are two solutions. You could have one, and I could have none, but at most we could have two. We need to kind of keep that in mind as well as we go through this. Okay, but if you kind of notice here, you have an x and an x squared. You cannot ever eliminate those. So they got to have the same term, and those do not have the same term. They're not like terms because one's squared and one is not, but I can cancel out my y's. So if I multiply this top one by -1, I get -2x plus y equals 4. So if I add what we have here, 2x squared minus 2x, that is not 0, that is 2x squared minus 2x. These do cancel, y minus y, or -y plus y, and this equals 4. And we're going to be factoring using the quadratic formula. Well, I think we're just going to be factoring, but we're going to be having a lot of quadratics in this one. So, because I have a quadratic, we need to get everything to the same side. So I have 2x squared minus 2x minus 4 equals 0. Let's try factoring first. If I'm factoring, I do want to take out my GCF, and I do have one here. They can all be divided by 2. So I'm going to pull out that 2. And that leaves me with x squared minus x minus 2 equals 0. So my a times c is 1 times -2. And my b term is -1. What adds up to -1 and multiplies to a -2? Hopefully you've had some time to think about that. That is going to be -2 and +1. -2 times +1 is -2, but when you add, you get to that -1. This is now an easy trinomial because I factored out that 2. If I don't factor out that 2, I have to rewrite the middle term and factor by grouping. But because I pulled it out, now my trinomial is easy. So this becomes x minus 2, x plus 1. This 2 here doesn't give me a solution, but I do get a solution of x equals 2 here, and a solution of x equals -1 here. Right, because you're doing x plus 1 equals 0 subtracted over. You are doing x minus 2 equals 0, adding it over. Okay, these are only half of our ordered pairs. These are both my x coordinates, so I'm guessing we're getting 2 solutions. So now I need to find my y. So plug it in. Let's go with x equals 2. And if I plug it into the top one, we get 2 times 2 minus y equals -4. So this is 4 minus y equals -4. Subtract your 4 to get y equals -8. And then divide by -1 to get y equals 8. So this ordered pair is 2, 8. Okay, do the same thing when x equals -1. You can use either equation. I'm going to use the top one again. So you get 2 times -1 minus y equals -4. This is -2. Add your 2 to get y equals -2. Divide both sides by -1. And we get y is 2. So this is x, comma y. My ordered pair is -1, 2. Okay, this is what we're going to be doing all lesson. So notice here I could use elimination because we had one of them that at least had common or like terms. Okay, here I have no like terms, so I cannot use elimination. You cannot eliminate an x with an x squared and a y with a y squared. So here you have to use elimination. Now first, let's just kind of mention what we have here. You have x to the first, y to the first. That is a line. And you have x squared, y squared. That would be a circle, but with that minus, that makes it a hyperbola again. So let's think about how many solutions we could have. And I think if you have go super wide hyperbola, you could maybe get 4 solutions there. Okay, so at most 4, but that looks really hard. So I bet you if anything, it's 2 or less. But we need to keep in mind what the max number is, okay? So because I cannot use substitution, or sorry, elimination, we have to use substitution. So this one here has a positive coefficient, so I'm going to solve for this y here. So if I solve for this y, that is y equals add your x over, and that's going to be x minus 9. So then, now that I have solved the top one for y, I'm going to substitute that in here into the bottom one. So in place of this y, I am replacing it with x minus 9. So I get x squared minus, plug in your y, it's y squared equals 81. So plug in your y where you see your y, which is x minus 9. So we get x squared minus, okay, x minus 9, quantity squared is not x squared plus 81. You have to expand this out to x minus 9 times x minus 9, FOIL, combine your like terms, and we get x squared minus 18x plus 81, and that equals 80. Okay. Distribute this negative, and we get x squared minus x squared plus 18x minus 81 equals 81. Well, x squared minus x squared, that's 1 minus 1, that's zeros. So I actually just have a linear equation, not a quadratic, because my squares cancel. So let's solve for x by getting x by itself. So we're going to add that 81 over to get 18x equals 162. Divide by 18, and we get that x is 9. So that's only half of my answer. I need the other half by getting y. I can plug it into either at the top, but I'm going to plug it into where y is already solved for. So this is y equals 9 minus 9. So y is 0. So my ordered pair is 9, 0. x comma y. This is what the rest of the lesson is. So we got 4 more examples with slightly different different things that can happen, right? But this is what the whole lesson is. Okay, here, let's name what we got. This is a circle because it's plus and the coefficients are the same. And here, because you have one that's not squared, but one that is your parabola. So if I have a circle and a parabola, I could have as many as 4 solutions there. So let's see what we get. Here, because I have y squared, I'm going to cancel out my y squares using elimination. I cannot do anything with these x's because one's squared and one is not. Those are not like terms. So I'm going to multiply the top one by -1. And that gives me negative x squared minus a y squared, and that's going to equal -4. I'm not looking at this top one. At this top one anymore. You have a positive y squared and a negative y squared. So those are going to cancel. And you actually have a +4 and a -4 here, so those will also cancel. So when I add what is left, I've got negative x squared minus x. I still have an equal sign, and so what do we have over here? Well, if that cancels, then we have 0. Okay, so we have a quadratic. And let's factor out our GCF. We have a GCF of x, or I personally like my x always positive, my first term always positive. So I'm going to pull out a negative x, which leaves me with x plus 1. So here you get negative x equals 0. Divide by -1 and x is 0. And here we have x plus 1 equals 0, subtract it over and x equals -1. So now let's substitute this back in. I'm going to substitute this in with the one that only has one squared term. And so when x equals 0, I get -0 plus y squared equals 4. That goes away. So I have y squared equals 4. The opposite of y squared is the square root. So we get y equals, the square root of 4 is 2, but don't forget that's the plus or minus of it, right? Because -2 squared is also 4. So when my x is 0, my y is 2 and -2. So we get 2 ordered pairs when x is 0. Sorry. Okay, let's do the same thing when x is -1. If I plug it in here, we have -1 plus y squared equals 4, right? This negative from this one, negative on the inside because that's what I'm plugging in. So this is 1 plus y squared equals 4. Subtract your 1. Y squared equals 3. The opposite of squaring y is to take the square root. So now we get y equals not just the square root of 3, but also the negative square root of 3. So plus or minus square root 3. So when x is -1, we get -1 square root 3. And we get -1 common negative square root 3. So this is one like this that we're going to get 4 different solutions. Here we have the same two types of equations. This is a circle because you got squared terms adding same coefficient, and you have a parabola because you got one squared and one not. Okay, so we already did that. That's a circle and a parabola. We could have as many as 4 different solutions. Now, with this one, it looks like it is set up for substitution. And we are going to end up using substitution, but you need to be careful when you do this. If I was to substitute this in, notice I'm bringing out a separate sheet of paper, so I would not write this down unless you think you've got room to. Okay, if I substitute this in the way it looks, and I substitute this in place of this y, we would have x squared plus, place of this y, I am doing x squared minus 9. Right here, this is going to give you an x to the 4th. This is x squared plus, when you expand this out and FOIL it, this is x to the 4th minus 18x squared plus 81 equals 4. I don't want to deal with polynomials to the 4th degree. So I don't want to substitute this in the way that they have this wrote. Okay, but we still can use substitution. If you would like, you could subtract this x over and then it's set up for elimination because you have a positive x and a negative x. Okay, that would 100% work. But if you want to use substitution, I'm going to take this equation here and rearrange it for my x squared. So I'm going to get x squared equals, I would add that 9 over, and so we'll have y plus 9. And now I'm going to substitute in where I see an x squared here. I'm going to replace this x squared with y plus 9. Replacing this entire term, not just the x, but the entire x squared term. So this is y plus 9 plus y squared equals 4. Okay, so we have a quadratic. So I'm going to have y squared plus y. We're going to subtract that 4 over, plus 5 equals 0. We always want to try factoring first. So a times c is 5. My b term is 1. What adds up to 1 but multiplies to 5? Well, the only multiples of 5 is 5 times 1, and that gets me nowhere close to 1. So because this is nothing, I can put here, nothing equals, yep, guys, you guessed it. Hopefully you guessed it, the quadratic formula. Yeah, we're not done with that. So my quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. From here, I know that my a is 1, my b is 1, and my c is 5. So I get -1 plus or minus the square root of 1 squared minus 4 times 1 times c all over 2 times 1. So -1 plus or minus the square root of something all over 2. Here we get 1 squared. 4 times 1 times 5 is 20. So 1 minus 20 is -19. This negative tells me that we have what? An imaginary number. Imaginary numbers are going to equal no solution. So even though my graphs could have looked like this, we either had something like the parabola with a circle maybe below it, or you could have had the parabola going around the circle. Okay, but either way, those two graphs are not intersecting at any spot. Okay, so as you can see, we've kind of had different variations of these. So while it's all the same, it's all a little different, right? Okay, on E, this one looks like it is set up for substitution. Is this a good one to use substitution on? Or if I substitute it in, do we get something to the fourth or to the third or to something else I don't want to deal with? This one ends up working for substitution, so let's just roll with it. And in fact, you can't use elimination here because if you subtract this x over, you have an x and an x squared, and you have a y and a y squared. So elimination isn't even an option. So in place of this y here, let's replace it with x plus 2. So we get 4x squared plus x plus 2 squared. This is going to equal 4. So 4x squared. When I multiply this, you got to expand it, FOIL combined. We get x squared plus 4x plus 4 equals 4. So we got a quadratic. So let's get everything to one side and let's combine our like terms. 4 plus 1 gives me 5x squared plus 4x. We're going to subtract our 4 and it cancels both. So this equals 0. So we do have a quadratic. Because it's missing c, we have a GCF of x, which leaves me with 5x plus 4. Here you get one solution when x equals 0. And here when I set 5x plus 4 equal to 0, I'm going to subtract my 4, divide by 5, and we get x equals -4 over 5. So let's substitute these back in to get our y values because I got two x values. The top one is by far going to be the easiest one because it's already solved for y, the variable we need. So when x equals 0, we get y equals 0 plus 2. So y equals 2. So one solution is 0, 2. My second solution is x equals -4 over 5. So we've got y equals -4. -4 over 5 plus 2. Use your calculator and you will get 6 over 5. So the ordered pair here is -4/5 and comma 6/5. Now, just to make sure we are all good on this, we know how to put that in our calculator. -4/5 is just division. That is -4 divided by 5. So -4 divided by 5 plus 2. Go math right here. Math. Convert it to a fraction, and that's your 6/5. And let's rewind because we should have went over our shapes, right? Here, we have a line. 1, that's my y equals mx plus b form. And 2, you have x to the first, y to the first, that's a line. Then here, we have an x squared and a y squared. It is being added and the coefficients are different. We finally have our first ellipse. So we would have had some kind of oval and then my line going through. So that is at most the amount of solutions we could have with that. And then lastly, let's go over our shapes again first. Here you have x squared, y squared. Because it's a minus with both terms squared, we have a hyperbola. And then here you have square terms again, they're being added, and my coefficients are different again. So we have another ellipse. So if I have my ellipse, and I have a hyperbola going through, here we can have 4 solutions. So let's see what we get. Okay. Well, you have both x squareds and both y squareds. So this one we can use elimination. And to use elimination, I need these all to be lined up. So I need to move my 20 over. And so when I move my 20, this is going to be -20 over here. And then we can eliminate our x's or our y's. It does not matter since they are both squared. I'm going to eliminate y's because you already have one positive and one negative. So if I was to multiply this bottom one here by 6, I'm just going to rewrite these over here. My top one doesn't change. But my bottom one, multiply all 3 terms by this 6. So this is 24x squared plus 6y squared. 6 times 20 is going to give me 120. All right. My y squareds cancel because one's a -6, one's a +6. And then we add what is left. 1 plus 24 gives me 25x squared. -20 plus 120 is a +100. So we do have a quadratic, but I have no b term, I have no x. So this one is set up for square root property. So let's get this x squared by itself by dividing over our 25. That gives me x squared equals 100 divided by 25 is 4. And then here, the opposite of squared is square root. So we'll take the square root of both sides to get x equals plus or minus 2. Don't forget the minus here. So when I substitute in, when I have x is +2, and let's substitute into the bottom one. Doesn't matter which, right? But I'm just going to pick the bottom. So we get 4 times 2 squared plus y squared equals 20. Order of operations says exponent first. So 2 squared is 4 times 4 is 16. Subtract your 16 over. And so to get rid of that squared, again, the opposite of squaring is square root. And so we get y equals plus or minus 2. So when x is 2, y can be 2. And when x is 2, y is also negative 2. So I get 2 solutions here when x is 2. So let's see what happens when x is negative 2. I'm going to plug it into the same one. So we've got 4 times negative 2 squared plus y squared equals 20. Again, order of operations tells me exponents first. So negative 2 times negative 2 is positive 4 times 4 is 16. And what do you notice here, guys? I got the same equation. So y here is also going to equal plus or minus 2. Subtract your 16, take the square root. So when x is negative 2, kind of hard to read, and x equals negative 2, it can equal positive 2. And when x equals negative 2, it can equal negative 2 as well. So this is one like this where we do get our 4 equations. So the last 6 examples were all the same things with just kind of slightly variations. The biggest thing I want you to be aware of is when it is set up for substitution, like this one was here, make sure when you substitute in, you don't get something other than a squared. You want to just have squares at max because we know how to solve quadratics by factoring square root property or quadratic formula. And then the other thing you want to be aware of is, let me find it, is one like this, where you have to use substitution because you have no like terms, right? You have an x and an x squared and a y squared, so you cannot eliminate those. And likewise, when you're given a problem like this, you are forced to eliminate the y's because again, those x's are unlike terms. So that is the end of this lesson and the end of this module.